Hey guys, this video is following the cylinder video of surface area and volume. This is spheres, surface area and volume of spheres. So a sphere is really sort of the way a little kid might describe a 3D circle, I guess. So if you had a circle and you were to revolve it around one of its diameters, it would make a sphere. You could also picture it as those sorry, my dog just, Dal, you can't do math, okay, bud? Get off the desk. Sorry. He learned to jump on the desk, so now he wants to hang out. Sorry. Tell us. What was I saying? Oh, those little party balls that like, like that's my reenactment. So it's like those party puffy tissue paper balls that they sell at like the party store that you like start with this semicircle, right? A little semicircle, and then it goes like this, unravels. I'll try to put one in the video so you could see what that's all about. But that's really how we could define a sphere. Or it could be, if it's like a solid sphere, we could also define it as a collection of all of the points that are less than or equal to a certain distance away from a fixed point, the center, in three-dimensional space as opposed to in two-dimensional space. So same idea as a circle. Many different ways that you are going to interpret this. Here we have the area or surface area formula, and here we have the volume formula. So I'm going to do what I did in the cylinder video, and I'm going to start off by redrawing the picture, give you guys some advice on how to draw 3D pictures, and then rewrite, chat it up and explain it a bit as we go, and then we'll try this example. Okay? So what do we do when we have to draw a sphere? I actually like to draw it a little bit differently than the picture that's provided here. What I like to do, and if you have to trace a circle, trace a circle, but take your time. Now I'm actually good at drawing big circles, not so much this little guy. So I draw a circle, and then I draw the center point. Then I kind of put a belt on it like they did, but I also add another line. So in the front, I'm going to do a long dashed line. In the back, I do a very dotted dashed line. And then kind of the same idea in the front here. I pick one side and I do a long dashed line and then a very dotty dashed line. So you could add more lines if you want. You could kind of shade things in. We could look at the radius now as being right there, or we could look at the radius as being right there, or we could look at it as being right there. All right, or, oh, that's not too straight, right there. So I'm going to go and trace this radius in a pink highlighter. So everything pink is going to be length R. That has a length of R. This has a length of R. This has a length of R. That has a length of R. I could even go and, strangely, and some people struggle with seeing this, so if you don't understand, don't stress yourself out, but I could just say it's like touching right here on the surface of the sphere, so it's not really going on this flat circle here or that circle there that I drew. It's sort of its own free spirit of a radius, kind of branching off in its own direction. So those are all radii, okay? Now, there's my drawing. I'm going to just add in the only variable we work with, which is the radius. So R, and what I'll do is I'll just highlight it in pink because, I don't want to label every single one of them. And maybe I should go over that with a darker marker for you. There we go. Okay, now the surface area formula. So the way I was taught surface area and the way I kind of still remember the formula once in a while to this day is I picture a baseball, and a baseball has those little stitch marks on it. So now I'm just drawing another circle for this part. So baseball, softball, I think they're made the same way, right? And it has like this kind of a look like that, and then these stitch marks or something, right? Like sewn like this. So let's pretend that we unstitched the baseball. So it's made of some kind of a leather material, right? If you unstitch this baseball, what shape will these pieces be? Well, they're kind of like these infinity symbols. You'll have one this way, and you'll have another one this way. Can you kind of picture that? So if you think about it, the baseball, what is it made of? Well, it's made of 1, 2, 3, 4 circles. Since it's made of 4 circles, the surface area is 4 pi r squared. Surface area equals 4 pi r squared. Pi r squared is the area of each of those circles. Obviously, it's not perfect, but and this is not an estimation. 4 pi r squared is actually the precise area, surface area of a cylinder. This is just an estimation by my weird little sketch, but it's because these aren't really perfect circles, and you have the extra material here, and you're missing material there. So it actually ends up working itself out. And the volume, well, the volume is 4/3 pi r cubed. I want to explain it using calculus, but for right now, let's just remember that cubed is for 3-dimensional. It's got that 4, but it's got this extra 3 right here on bottom as well. You're going to see 1/3 involved in a few other volume equations, so like cones and pyramids. So 3 in the denominator happens for a lot of volume equations. So for right now, I'm just going to write it as a formula. Volume is 4/3 pi r cubed. Spheres are special, and we could be pretty specific because we don't really work with a lot of 3D figures that are quite like a sphere. So let's go ahead and try this example now that we wrote these equations down. So I'm just going to separate them so that they don't get mixed up in my work. So here I have my sphere. And again, I'm given a diameter of 18 inches instead of the radius. If you have that the diameter is 18 inches, that means that the radius has to equal 9 inches. Now, if we go to find our surface area, 4 pi r squared, because I'm going to remember my little baseball trick for the rest of my life, right? You too? 4 pi. Radius, we just said, was 9 squared. 9 squared is 81. 81 times 4, well, you can do 81 times 2 is 162. Times another 2 is 324. So we get 324 pi. Now, 9 was actually 9 inches. 9 inches times 9 inches is 9 times 9, and inches times inches. What's inches times inches? Inches squared. So my exact surface area is 324 inches squared. Next, the volume. Volume equals 4/3, think 3D, oh, that's a good trick. Look, I just made one up. So 3D, 3 in the denominator. Get it? Oh my gosh, sometimes I impress myself. 4/3 pi r cubed. Now, that 4 is unique to the sphere. The cone and pyramids have a 1/3, not a 4/3. So that 4 is special here. Think of it as the 4 circles on the outside of the baseball. Volume equals 4/3 pi 9 inches. I'm going to write it like this time, cubed. So this time we have 9 times 9 times 9. That's 9 cubed. What is 9 times 9 times 9? If you know 9 cubes by heart, which is something I did try to practice with you guys throughout the year and at the beginning of the school year, but if you don't know it, it's 729. Try to memorize your cubes up to a certain point. Cubes, squares, it's going to just come in handy. Now, if I divide by 3, I could have really crossed out a 3 from the beginning and made it 9 times 9 times 3. If I had done that, I would have gotten 243, but then I still have to multiply by 4. If I multiply by 4, I will get 972 pi. The pi's not cubed. Inches is though, so inches times inches times inches is inches cubed. The volume of this sphere is 972 pi inches cubed. That's really the end of our sphere example. You could find now the volume of lots of interesting things. So if you wanted to find the volume of the planet Earth, right? You can find the volume of our planet. The radius of Earth is approximately 3,960 miles. Handy thing to know when someone tries to randomly challenge you on your knowledge of how long it would take to travel around the Earth if you were traveling in a rocket at this speed. Not that that happened while I was watching the space launch the other day or anything. It did. And I was able to do it and say it and know the answer and look like a weirdo smart person. So 3,960 miles radius of the Earth. Obviously, it's not perfect because Earth is pretty lumpy. And that's all for spheres for right now. So I hope this helps. And the next one we're doing is cones. See you in the next video.